Today I'll solve one numerical problem on bubble point pressure and vapor composition for a liquid mixture. Here is the problem statement. Find the bubble point pressure and vapor composition for a liquid mixture of 41.2 mole percent ethanol and n-hexane that at 331 Kelvin. Now here that Van Laar activity coefficient is given, that is ln gamma 1 is equal to a by 1 plus that ax1 by bx2 that whole square, and this is for this ln gamma 2 the equation, and a is 2.409 and b is 1.970, and vapor pressure in kPa equation for ethanol and n-hexane, that is Antoine equation, is also given. Okay, so from here we have to calculate that bubble point pressure and vapor composition for a liquid mixture of 41.2 mole percent ethanol and n-hexane at 331 Kelvin. Now here T is given, T is 331 Kelvin. So using given equation, means using that Antoine equation, we can easily calculate the vapor pressure. So P1 set, after plugging this value, so here that Antoine equation is given. So if I plug that T value, that 331 here, so we'll get P1 saturated, so that is 42.9 kilopascal. Similarly P sat, using this Antoine equation, so here if I plug T, so we will get that P2 is 70.54 kilopascal. So that saturated vapor pressure, so P1 sat is 42.9 kilopascal and P2 sat is 70.54 kilopascal, that we got from this Antoine equation in particular temperature, that is 331 Kelvin. Now x1 is given, so that is 0.412 mole fraction of ethanol. So we can easily calculate what will be the mole fraction of n-hexane. So that is x2 is nothing but 1 minus x1. So that is nothing but 0.588. Now from here we can easily calculate the activity, that gamma 1 and gamma 2. So gamma ln gamma 1, so that equation is already given. Okay, so a1 and b1 is given, so we plug that x1 x2, we can easily get that ln gamma 1. So ln, if I plug this all these values, so ln gamma 1 will be 0.699. so from there we can easily calculate gamma 1 is nothing but 2.011, and ln gamma 2 similar way, plug all these value, so gamma 2 will be 1.521. so gamma 1 is 2.011 and gamma 2 is 1.521. After getting gamma 1 gamma 2, so now we can calculate the partial pressure ethanol, so that is P1 x1 gamma 1 P1 set. So x1 is 0.412 and then that gamma 1 we got 2.011 and P1 set we got that 42.9. so ultimately P1 is 35.55 kilopascal. Similarly partial pressure of n-hexane, so P2 is nothing but x2 gamma 2 and P2 set. So if I plug all these values, so we'll get that P2 is 63.09 kilopascal. So ultimately bubble point pressure will be sum of all these P1 and P2, so that will be P1 and P2 35.55 plus 63.09, so that is 98.64 kilopascal. So here the bubble point pressure is 98.64 kilopascal. So now vapor composition. So mole fraction of ethanol in vapor phase, so y1 is nothing but P1 by P bubble. P1 we got that 35.55, so by P bubble is 98.64, so that is 0.360. So mole fraction of the ethanol in the vapor phase is 0.360, that is 36%, and then mole fraction of n-hexane in vapor phase, so y2 is nothing but 1 minus y1, so that is 0.640, so 64%. That's it.